Hello everyone, welcome to this lecture. In today's video, we would like to write a program in C++ to calculate the sum of the series here, okay, this series. In parentheses, 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 3 plus 4 multiplied by 4, etc. until the end n multiplied by n. So let me first run the code once, and then we're going to dive deep into the details. So enter the value of n. So we saw that it can go until n multiplied by n. So if I want to have only the calculation of the sum of this series for the first part, I would say number 1. So only 1 multiplied by 1 is calculated and the output is 1. Okay. So when I run the code one more time, when I type down 2, and we are having 1 multiplied by 1 plus 2 multiplied by 2. So this one is 4, and this one, the outcome is 1. 4 plus 1, the output is 5. Okay. And for example, if I have number 5 as the input, we are going to start from 1 multiplied by 1 plus 2 multiplied by 2 plus, and it is going to continue until 5 multiplied by 5. So the output is 55. So this is the series that we would like to calculate its sum, and we would like to have its sum in C++, and we would like C++ to help us to calculate the sum of this series. To do that, first of all, we are having two variables. The first variable is n. It's of integer type, so this is the number of terms in the series that we want to have. And then we are having one integer called sum. It is initialized to be 0, and it is the variable that we are going to use to store the sum of the series. After that, we are going to ask the user to enter the value of n. For example, the user is going to enter 2. It means that they want to have this series. So 1 multiplied by 1 plus 2 multiplied by 2. So when the user is going to choose n to be equal to 2, it means that they want the sum of this part of the series. If they're going to choose 5, it means that they're going to have it like this, okay? So they're going to have it from 1 multiplied by 1, sorry, until 5 multiplied by 5. So we are going to ask the user to enter the value of n, and we are going to store it in the n using the cin. Then we are going to have a for loop to do the calculation of the sum. We are going to have a for loop starting from 1. It is going to continue as long as I is lower than or equal to n, and I is going to increase by 1 unit in each iteration. After that, in the next line, we are having sum plus equal I multiplied by I. So for example, this line means that we can have sum equals sum plus I multiplied by I, okay? So this equation here is exactly equal to this one, okay? So it depends on us. Which one you want to write down, it's okay. It's your choice. But they're going to do the same thing in terms of mathematics. So if, for example, the user is going to enter n equals 3, we are going to have 3 iterations. For I equals 1, because we start from 1 in the for loop, I equals 2, and I equals 3. I equals 3 because I can increase as long as it is lower than or equal to n, and n is 3, so I is going to take 3 as well. So in the first iteration, when I equals 1, sum equals sum plus 1 multiplied by 1, okay? So the output of this will be sum equals 1. Why? In the first iteration, I equals 1. Sum equals sum plus 1 multiplied by 1. Why 1 multiplied by 1? Because this is the formula. Sum equals sum plus I multiplied by I. So in the first iteration, I equals 1. Therefore, we are having I multiplied by I. So 1 multiplied by 1 is the result of this. And then we are having the sum in the formulation, and sum was initialized to be 0. Therefore, 0 plus 1 equals 1. So sum is 1 for the first iteration. Then I equals 2. So sum equals sum plus 2, multiplied by 2. Okay. So sum plus 2 multiplied by 2. And already sum equals 1 from the first iteration. We know that sum equals 1. Plus 2 multiplied by 2 is 4. So 1 plus 4, it means that sum equals 5. In the third iteration, which is the last iteration, because we assume that n equals 3, for example, we are going to have sum equal sum plus 3 multiplied by 3. This means that 5 plus 9. We are having 5 plus 9. 5 comes from the last iteration of sum, so sum equals 5 already. And then 3 multiplied by 3 is 9. Therefore, we are going to have the sum equal 14. This is how we're going to use it. So in the last iteration, sum equals 14. And now if we want to increment the value of I equals 4. 4 is lower than 3. No, this statement is not true. Therefore, the for loop is finished. And now we are going to see out this message to the user saying that, for example, the sum of the series 1 multiplied by 1 plus 2 multiplied by 2, etc. equals sum. And the sum is getting this value for n equals 3. So when I run the code one more time, I enter the value of n, I enter 3, and we see that the calculation that we did was correct. So because the output is 14 here, and we also had this 14 in the calculation ourselves. So when we enter number 3, it means that we want the series to be 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 3. Therefore, the output is 14. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to display the cube of the number up to an integer. For example, if I enter n equals 5, I would like the C++ to calculate cube of 1, cube of 2, cube of 3, cube of 4, and finally cube of 5. And cube means, for example, cube of 2 means 2 multiplied by 2 multiplied by 2. So if number 2 is multiplied to itself 3 times, it means the cube. So 2 multiplied by 2 is 4. 4 multiplied by 2, it's 8. Okay. So if the user is going to enter n equals 5, we are going to write a program to calculate the cube of 1 up to 5, from 1 to 5. Okay. To do that, we are first of all having a variable called n, and we are going to ask the user to enter the value of n. Whatever the user is going to enter, we are going to store it in n. Then we are going to show this message, number and cube. \t helps us to have a big space between two numbers or two strings. When we are having number \t cube, it means that put the number here and provide a large space and then put the cube afterwards. Okay, so we show this message to show the first column is numbers and the second column is the cube of the corresponding number. Then we are having a for loop starting from 1, and it is going to continue as long as I is lower than or equal to n. Then in the for loop, we are going to first print the value of I, and then provide a big space using \t, and then calculate the cube of I. For example, in the first iteration, I equals 1, okay? We are going to have 1 and then one big space and then another 1. It's the cube of 1 is 1. Then I equals 2, we are having 2 and one big space, and then we are going to have 8, its cube. And then we are going to have 3 and then its cube, which is 27. So when I run this code, we see enter the value of n. For example, I type down 3. It says number, and you see there is a space here. It's because of \t and then cube. The number 1, its cube is 1. Number 2, its cube is 8. Number 3, its cube is 27. So we enter number n equals 3, and it is going to calculate from 1 up to 3 the numbers and their cube. How we do that? We are using a for loop. We are using a for loop. In each iteration, we are printing I, and then we are calculating if I multiplied by itself 3 times. And in each iteration, I is taking one value. For example, then first of all, it takes the value 1, then it is increased by one value, so it is taking number 2. In the next iteration, it is taking number 3, and it is going to continue up to it is equal to n, which is the entered number by the user. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that displays the sum of n odd natural numbers. Here is what we mean. For example, if n equals 2, it means that I would like to have the sum of 1 plus 3. So the first two natural numbers. Then if n equals 3, for example, or let's say 5, it means that I would like to have the sum of 1 plus 3 plus 5 plus 7 plus 9. So these 5 numbers, the first 5 odd numbers, this is what we mean. So if the user is going to enter n equals 5, I would like to have the calculation of the sum of the first 5 odd numbers. To do that, we are having an integer called n, and then we are having a sum that we are going to use to store the variable sum in this variable called sum. It's of integer type, and first of all, we're initializing it to 0. Then we are going to ask the user to enter the value of n, and whatever the user is going to enter, we're going to store it in n. For example, the user is going to enter 2, and then we are going to calculate the first two odd numbers summation, 1 plus 3. And if the user is going to enter 5, for example, we are going to have the sum of the first 5 odd numbers. Then we are going to have a for loop starting from 1, and as long as I is lower than or equal to n, we are going to continue this for loop. And then in order to find the odd numbers, we can have this formula. So sum plus equals 2 multiplied by 1 minus 1. And this equals sum plus 2 times I minus 1. This one is also I, it's not 1. So this formula is exactly this formula. They're doing the same thing. So it means that in the first iteration, for example, when I equals 1, let me test to see if the formula that we provided is working or not. So if I equals 1, it means that sum equals 0 plus 2 multiplied by 1 minus 1. Okay, it means that sum equals, why we are having 0 plus this number because sum plus this formula, and I equals 1, so 2 multiplied by 1 minus 1, and sum equals 0 because we initialize it to be 0. Therefore, sum equals 2 multiplied by 1, the output is 2 minus 1, it will be 1, okay? Then we are having I equals 2, sum equals 1 plus 2 multiplied by 2 minus 1, okay? This means that we are having 1 plus 2 multiplied by 2 is 4 minus 1, it will be 3, okay? And then we are having 3 plus 1, therefore sum equals 4. And I equals 3, sum equals 4 plus 2 multiplied by 3 minus 1, and the output will be 4 plus 2 multiplied by 3 is 6 minus 1, it's 5, therefore sum equals 9. So for example, if the user is going to enter n equals 3, it means that we need to calculate the sum of 1 plus 3 plus 5, and this sum will be 9, okay? Here we did the test for 3 iterations, so when I equals 3, the sum will be equal to 9. And how we did the computation, we used this formula to get only the odd numbers. If you see here, when we are using this formula, when we are implementing for the first iteration, 2 multiplied by 1 is 2 minus 1, it will be equal to 1. So 1 is an odd number, so we are having it to assigned to sum. Then we are having in the next round, we are calculating 2 multiplied by 2 will be 4 minus 1, it will be 3. And 3 plus the previously calculated sum, which is 1, it will be 4. So the summation of 1 and 3 is 4. Okay, the first two odd numbers. Then in the third iteration, we are having 2 multiplied by 3, it will be 6 minus 1, it will be 5, and 5 is added to 4, and 4 was the calculation of 1 and 3. 1 and 3 is 4, and then we are adding 5 to this 4, so the sum equals 9. This is how, in fact, we are going to calculate the sum of, for example, first 3 odd numbers. When I enter the value n equals 3, it says the sum of the first 3 odd natural numbers is 9. So this is how we can have their summation. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the number and sum of all integers between 100 and 200 which are divisible by 9. It means that we would like to have a for loop starting from 100 to 200 if the numbers are divisible by 9. We would like to know and display them. We would like to know them and display them, and also calculate their sum. Okay, here is how we can do it in C++. I'm having two variables called count and sum, both initialized to be 0. Then we show this message: numbers divisible by 9 between 100 and 200 are. After that, we're going to loop through the numbers from 100 to 200. We are having our iterating variable called I. It is going to start from 100 and it is going to continue as long as I equals 200. After that, in the for loop, we are going to first check this condition. If I divided by 9 and the remainder of this division using the modulo operator equals to 0, it means that that I is divisible by 9. Therefore, see out that I, then increment the value of count, which was set to 0, and then add that I to the sum. So what happens is the following. So first of all, it is going to show that I, okay? Then increase the value of count variable by 1. So we know that, okay, now we are having between 100 and 200, we are having 10 numbers that are divisible by 9. Using the count plus plus, we are going to understand how many numbers. I'm going to explain how. And then we are having sum plus I. Sum equals sum plus I. Sum was initially 0. Then we are having in the first iteration, we are adding that number that is divisible by 9. Then if we are having another number, we are going to also add that as well, etc. until the end. And how basically this count works is the following. For example, when we are having count equals to be 0, we check to see if I is divisible by 9. If so, it means that the remainder of their division equals to 0. If this statement is true, we are going to implement this part. First of all, we are going to display I. Then we are going to increase the value of count by 1. So exactly like this, okay? We were increasing the value of I in our loop after each iteration. So every time that we find an I that is divisible by 9, we increase the value of count by 1 value. So if, for example, 10 times we enter this if condition and we find 10 numbers that are divisible by 9, we are going to have the count equal to, for example, 10. So let me run the code. When I run the code, it says numbers divisible by 9 between 100 and 200 are 108, 117, 128, 135, 144, etc. until 198. So total numbers divisible by 9, 11. So this is the output of count because we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we entered this if condition. We entered this if condition 11 times and we printed out the I as you see here. So in the first time that I is divisible by 9, it is I equals to 108. So count was 0. Now it is incremented by 1 value. Now it is 1. Then we are having this next I that is divisible by 9 is 117. When we are having I equals 117, the remainder of the division that 117 is divided by 9 equals to 0. We are going to print 117 here. Then we are going to increment the value of count one more time. So initially it was 0. Then after the iteration of 108, we increased its value to 1. And now that we are having 117, we are increasing its value to 2, for example. And then we are having the sum of numbers divisible by 9. It is 1683. So if we calculate the sum of these 11 numbers, we get to this number. And this is the output of sum. In each iteration that we found an I that is divisible by 9, we print out it and we are going to add that number to the sum variable. Okay, so 108 is found, it is added to the sum that was initially 0. Then we found 117, 117 is added to the sum that was already 108 from the previous iteration. Then 126 is found, it is again added to the sum variable until the end, and we are having the sum 1683. Here is how we are showing the output. As you see here, the total number divisible by 9, and then we are printing out the value of count, and then sum of numbers divided by 9 equals to sum that we are printing in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to enter any number and print all factors of the number. Here is what we're going to do. We're going to ask the user to enter a number and we're going to store it in a variable called number that is declared to be an integer type. Then we are showing this message. Factors of number are, and then we are having a for loop starting from 1 until that number. So this iteration is starting from 1 and it is going to continue as long as I is lower than or equal to that number. Assuming that, for example, the user enters number to be equal to 20, we are having iteration from 1 until I equals 20. And in each iteration, we are increasing the value of I by 1 unit. Then we need to check if that number, which is 20, is divisible by I, and it means that the remainder of their division equals 0, we are going to print it in the output. So let me give you an example. So number equals 20. So 20 divided by 1, the remainder, if we want the remainder, we need to use the modulo sign. 20 divided by 1, then 20 divided by 2, the remainder, then 20 divided by 3, the remainder, until 20 divided by 20 and their remainder. So whenever the remainder of 20 divided by any of these i's equals 0, it means that that I is a factor of 20. Okay, and we're going to print that I. So let me run the code. First, it says enter a number, and I'm going to enter a number, for example, 20. It says factors of 20 are 1, 2, 4, 5, 10, and 20. It means that if 20 is divided by either of these numbers, the remainder of this division, of the divisions, is going to be equal to 0. For example, 20 divided by 1, the remainder equals 0. Okay. 20 divided by 2, the remainder equals 0. By 3, it's not 0. And then, for example, if we have 20, let me type it here. So we have 20 divided by 4, the remainder equals 0. 20 divided by 5, the remainder equals 0. And 20 divided by 10, for example, the remainder is 0. And 20 divided by 20, their remainder equals 0. So when I run the code one more time, it says enter a number, I say 20. So these are the factors of number 20. If I type down another number, for example, 36, we see that 36 has these many factors. It means that if 36 is divided by 1, the remainder equals 0. If 36 is divided by 2, the remainder of this division will be 0. If 36 is divided by 12, the remainder of this division will be equal to 0. This is how, in fact, we can find the factors of any number in C++. So let me review it one more time. We're going to ask the user to enter a number. We're going to store it. Then we are going to have a for loop starting at 1, and we're going to continue as long as I equals that number, that entered number. And we are going to say in each iteration, we check one if condition. If the number that is entered by the user in each iteration divided by I and the remainder of this division equals 0, it means that that I is a factor of our number. Therefore, we are going to print that I. Okay, so 20 is divided by 1, the remainder equals 0, we are going to print 1. 20 is divided by 2, the remainder of this division equals 0, we are going to print 2. 20 is divided by 3. The remainder of this division is not equal to 0. Therefore, this condition is not true, and we are not going to do anything. We are not going to print it because we are not even entering this if condition, because 20, when it is divided by 3, the remainder of this division does not equal 0. This is why we are going up again, and we are going to increase the value of I. This time I equals 4, and 20 divided by 4, the remainder equals 0. Yes, so we are going to print 4 here. Then 20 is divided by 5, the remainder of this division equals 0. Yes, we are going to, this condition is true, we are going to print 5. Okay, so the next iteration, I equals 6. 20 divided by 6, the remainder of this division equals 0. No, this statement is not true. Therefore, we are not going to enter this part, and we are not going to print the 6 in the output. This is why when we type down 20, we see 1, 2, 4, 5, 10, and 20. So this is how we can find a factor to any number in C++. Thank you for watching. Hello everyone, welcome to this lecture. In today's lecture, we are going to write a program that calculates the compound interest. In order to calculate the compound interest, we need to have 3 values. The first one is the principal amount. The second one is the rate in percentage. And also the third one is the number of years in which we are going to return the money. We are going to read this information from the user. So to do that, we initialize principal, rate, and time as doubles. And then we are going to ask the user using cout syntax to enter principal amount, and we are going to, whatever the user is entering, we are going to store it in principal. Then we are going to tell the user, okay, enter annual interest rate, and we're going to use the cin syntax in order to store the user input in the rate, and then we're going to get simply the number of years from the user and store it in time. After doing this, we're going to have the compound interest formula. So it's a common formula that we're going to write down here. We are having the principal times 1 plus rate divided by 100 to the power of years to the power of time, which is the number of years that we are going to repay this amount. So in order to have one number added to another and then being to the power of another number, we are going to use po keyword in C++. In order to be able to use this keyword in C++, we need to include this library. So CMath library is already included in the header. Make sure that you're going to include it. And then when we are writing down po, there are 2 arguments in the parentheses, and they are separated by a comma. The left-hand side is going to be increased to the power of the right-hand side argument. For example, if you type down po 3 to the power of 2, it is going to do the calculation like this. Okay, 3 times 3. Or if you type down po 5 times 3, it is going to calculate it to be like this. Sorry, like this. Okay, so this is the compound interest formula, and the only point that we need to be careful about is the use of the po keyword, which needs the inclusion of the CMath library in C++. So basically we have this formula to the power of the number of years, that is time here, and the rate is first divided by 100 because it is entered as a percentage, and then it is added by one value, then it is the result is going to be calculated to the power of time. And then when we have the calculation, the result is stored in the double called amount. We're going to show the output using cout. We are just mentioning the compound interest after, for example, 30 years is, and the amount minus the principal. So because this formula is going to give you the amount that you're going to pay throughout, for example, 30 years. And when this amount is reduced, the principal amount that you got is reduced from this amount, you're going to have only the compound interest. And the total amount is the amount. So let me just run the code first, and then we continue analyzing the code together. So when I compile, it is asking enter principal amount. I would say, for example, 1000. Then enter annual interest rate. I would say, for example, 4.5%. And then enter the number of years. So I'm going to get a mortgage, for example, from the bank, and I'm going to get $1,000 from the bank, and the interest rate for this amount of money is 4.5, and I'm going to return this money after, for example, 30 years. So when I enter, it says that the compound interest after 30 years is 2,745 approximately dollars, and then the total amount is this number. So let me analyze the code one more time. So here it is asking enter the principal amount. We enter that, it stores. Enter the annual interest rate. We are entering the annual interest rate, and then it is saying that enter the time. I say, okay, I'm going to give this money back in 30 years with this interest rate. Okay, it does the calculation here, and it shows the compound interest after 30 years. So this is the time that is being printed there. So it is printing 30 because we actually entered 30 ourselves in the first place. Is, so this number. So if you're getting 1,000 from the bank and you're going to repay in 30 years using this interest rate 4.5, you are going to pay $2,745 after 30 years more. So the total amount is 3,745. So you're getting 1,000 and you're returning 3,745, and the 2,745 of which is the interest that you're paying after 30 years with this interest rate. So it is a very interesting and practical example of how you can use basic knowledge in C++ and have a very useful program that calculates the compound interest for you. Thank you for watching. Hello and welcome to another lecture. Now we're going to write a program that calculates the distance between 2 points. In order to do that, we're going to initialize 4 doubles called x1, y1, and x2 and y2. x1 and y1 are corresponding to the coordinates of the first point, and x2 and y2 are corresponding to the coordinates of the second point. So we are going to show the user this text saying that enter coordinates of the first point, x1 and y1. And then using cin, we are going to store x and y accordingly, x1 and y1. Then we are going to again show the user enter the coordinates of the second point, and the user is going to enter two numbers, and x2 and y2 is then stored using cin syntax and keyword in C++. In order to write down the formula for computing distance between 2 points, we need to include the CMAF library function in C++ in the header. So please make sure that you're including this header in your code. And then we're going to simply type down the formula. So it is a well-known formula that is going to compute the square root of the x2 minus x1 to the power of 2. This is the first part of the formula, plus the y2 minus y1 to the power of 2. So after doing these two parts calculation, the output is going to be added to each other, and then we are going to calculate the square root. So for example, if x1 equals 5 and x2 and y1 equals 2, for example, and x2 equals 10, y2 equals 5, for example, we are going to have this formula to be something like this: x2 minus x1, meaning that 10 minus 5 to the power of 2 plus y2 5 minus 2 to the power of 2, and all of it we're going to have a square root. So when we do the calculation, we are going to have 10 minus 5 will be 5, 5 to the power of 2 will be 25, plus then we are going to have 5 minus 2 is 3, and 3 to the power of 2 will be 9, and then we are going to have the sqrt of 34, and then the library function is going to calculate the square root of 34 for us. So this is how basically the steps is going through, but the important thing is to include the CMAF library function and to know how the PO function is working. So the PO function is going to have two arguments, the left hand side and the right hand side, and they are separated by a comma. So the left hand side, you put the main number, and on the right hand side, you're going to put the power. For example, if I type down PO 5 and 3, it is going to calculate number 5 to the power of 3. It means that number 5 is going to be calculated like this. So this is how the PO function is working, and also the square root is simply just doing the square root using this library function. So let me just compile and see the code. And I'm going to enter the same numbers here. So x1, so it says enter coordinates of the first point, enter coordinates of the first point, x and y, x1 and y1. So x1, I'm going to, because we are first storing the first number in x1 and the second number in y1. So the x1 equals 5, and then I would say y1 equals 2. Then it shows the message saying that enter coordinates of the second point, and the second point, the x2 is 10 and y2 is 5, and it is mentioning that the distance between the 2 points is 5.83. So this is basically how this code is working. You see that we can write very useful and practical codes even with very basic knowledge of C++. And please go ahead and do the exercise yourself, because it may look easy, but there are many parts that you need to be careful about, and you need to do the errors and improve from there. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we are going to write a program that generates a number between 1 and 100 and let the user guess the number. In order to do that, we need to include two library functions. First, ctime, and the other one is cstdlib. So make sure that you include these two. These are basically needed for generating a random number in C++. First, we need to know how to generate a random number. So in order to do that, we initialize the random number generating, using the current time as a seed using this line. And then we are generating an integer between 1 and 100 and assigning it to the integer target. And the formula for this right hand side is like this. So if you would like to have something between 1 and 100, you're going to have the max minus min plus 1, which in our case is 100 minus 1 plus 1, which will be 100, which is written here, plus the minimum, which is 1. But if you're going to have, for example, a random number between 20 and 30, you're going to have 30 minus 20 plus 1, and then plus 20, okay? And 30 minus 20 will be 10 plus 1 will be 11. So the formula for having a random number being generated between 20 and 30 will be like this. Okay, so depending on what you want, the range, you can simply choose it using this formula. Then we are going to initialize an integer number called guess, and the user's input is going to be stored in this integer. And then we are asking the user guess a number between 1 and 100. After that, we are going to define an infinite loop, so a while loop that is infinite because the condition for this while loop is true. So it is going to repetitively continue this loop until we break. Okay. Then when we are entering the loop, we are storing whatever the user is entering, and we are simply having an if-else condition here. So if the number that the user entered is lower than the generated number, simply sign that it's too low, try again. And if the number that the user entered is larger than target, it says it is too high, try again. And otherwise, if they are equal, means the else condition, because if guess is neither lower than target nor larger than target, it is going to be equal to target. So in this condition, say that congratulations, you guessed the number. So let me run the code once to see how it works. So guess a number between 1 and 100. So I'm going to write down 50. It says too high. I would go with 25. Too high. I would go with 13. Too low. I would say 20. Too high. 18. I would say then 15. It's too low. 16. It's too low. 17. So it says, congratulations, you guessed the number. You see, it was an infinite loop. So as long as I was not guessing the correct number, it was asking me again and again to enter a number. And when everything equals, when my number is equal to the generated number, it is going to break. And when it is breaking, it is getting out of this infinite loop here. So this time the number was 17, the generated number. So when I recompile, it's a new number. So I would say 50, it says too high, 25, too low. I would say 40, too high, 35, too low, 37, too high, probably 36. Okay, and it generated a new number that is 36. Okay, and it says congratulations, you guessed the number. However, if you don't consider this line of code, which initializes the random number generator using the current time as a seed, we will see that the number is not going to be generated in every run, and it is going to be one fixed number. So when I type 50, it says too high. If I type 36, it's too low. I would say 40 too low, 45 too high, 41, 42. So now the number is 42. If I compile again and I type down 42, it says you guessed the correct number. So I recompile again, I type 42, congratulations, you guessed the correct number. So it is important to include this line of code. So every time that you run, it, it provides a new generated number. So if I run now, it should be different. You see, it is too high. So I go with 20, it is still too high, 10, 15, too low, 70, 17. Okay, now it says, congratulations, you guessed the number correctly. So, and you see it is not 17 anymore. It is saying that it is too low when I type 17. So 50 too low, 75 too high, I would say 60 too low, 65 too low, 66, 67, 68, 69, and 70, 71, 72, 73. Okay, 73 is the number. So you guessed the number. So this is how we can generate a number between any given range and start um, letting the user to guess the the output, the generated number, and also you can go even further and let the user to choose only 3 times. So to guess only for 3 times. If they guess in the first 3 rounds, you give them a prize. Otherwise, you would say no, you lost, etc. So this is basically how it works with many machines that are for entertainment out there. Thank you for watching. Hello everyone, welcome back. In this lecture, we are going to write a program to calculate the factorial of a given number using a for loop. In order to do that, we do all the calculation in another function that is called factorial. And in the main function, we are just going to call the factorial function to do the calculation for us. But before that, we initialize and declare one integer called number. We'll let the user to choose the value for this number as the input, and whatever the user is going to enter, we're going to store it using cin keyword and or syntax in C++, and then we're going to show this message in the terminal saying that the factorial of number that is entered, for example, if the user says the factorial of number 5, it is going to show that the factorial of 5 is, and then it is going to basically call the function. So a function is having 3 parts. The main part is this part that is having the name of the function. So the name of this function is factorial. And before that, we are having the type of function. So it says that the output type of this function is going to be an integer. Therefore, when there is an integer here, we expect that this function is going to return an integer value in the output. So it is returning the result, and result is an integer declared initially here. And there are some calculation done about the result here that we're going to discuss. And then the third part of a function is the argument, which is in the parentheses. So one input or argument is allowed for this function, which is of type integer. So when we are willing to call a function, we are typing down the name of the function, and in the parentheses, we are going to pass the argument because it requires an argument to be passed. We are going to pass the argument, and we are going to pass the argument here that is number. So if the user wants to do calculation for the factorial of number 5, this 5 is going to be passed here. Then, when we're calling this function, and this part of the code is going to be executed. So it is going to initialize one integer called result to be set to 1. And then we are going to have a for loop. The loop is going to start from 1, and it is going to be repeated as long as I is lower than or equal to n. and then we are going to have the calculation over the result. So basically this line, this line means this equals result times I. So another form to write this equation is to write this equation. It means that whatever the value of the result is already there, make it multiplied by I and then store it in the result. So let me run the code first and show you how things are working here. So let me give you an example first and then we are going to run the code. So if the user is going to enter the number to be, for example, 5, okay? Imagine that the user is going to enter the number 5. So the user wants the program to calculate the factorial 5 for it. So basically, we are going to call the function with the number 5. It is going to initialize the result to be 1. And then in the first round, when I equals 1, because I starts from 1, and it is going to be continue until I is lower than or equal 5. So, and here, when I equals 1, it is going to have this function, this line of code, meaning that result equals 1 times 1. Why? So the first one is this one because we initialized the result to be 1. So this result is 1. Then it is going to be multiplied by 1. Why? Because it's a multiplication to I and I equals 1. So basically result is going to get the value 1 again. Then I is increased to value 2. We have the result equals to 1 times 2. It means that result will be 2. Why here it is also 1 again? Because previously we calculated a result to be equal to 1 and I equals 2 now. So we are having the multiplication by 2. So result equals 2. Then we are having I equals 3, for example, result equals 2 times 3. Why 2? Because the formula is result multiplied by I. So the result from previous step was 2 times 3, which is the value of the I. So it is going to calculate it to be, for example, result to be 6. Then I equals 4, then I equals 5. So let me run. If I say 5, it is going to say the factorial of 5 is 120. So when I equals 4, we are having 6 times 4, meaning that result will be 24, and 6 comes from the previously calculated result multiplied by 4, which is the value of I. So it is 25. And finally, when I equals 5, result will be equal to 25 times 5. This is going to be 120, which is the number that we saw here. So basically, using a function can help us to calculate the factorial of a given number. So if we would like to have the factorial of 3, it is going to say the factorial of 3 is 6. If I recompile again and say that the factorial of 10, it is going to do the calculation for the factorial of 10. So it is going to be 3,628,800. So this is the factorial of 10, for example. And please go ahead and do this exercise because we are reviewing in this simple exercise, we are reviewing how to get and store an input from the user, how to call a function, and everything about a function almost is being reviewed because the output the argument of a function, the name of the function, and it is going to return an integer value. So it is basically returning an integer value. So here we are calling the function, and in return it is giving us the result value here, the result integer. And then we are also reviewing how a for loop works in C++. Thank you for watching. Hello everyone, welcome to another lecture. In this video, we would like to write a program to check if a number is prime using a Boolean flag. So let us define the prime number first. So a prime number is a number that is greater than 1 and has exactly two distinct divisors. So it can be 1 and itself. For example, number 20 has many divisors, and the divisors are 1, 2, 4, 5, 10, and 20. It means that when 20 is divided by either of these numbers, like it is divided by 20 or it is divided by 10, it can be divided by, for example, 5, etc. When number 20 is divided by any of these divisors, the remainder would be 0. So it is not a prime number, because a prime number is only divisible by 1 and itself. However, when we are going to discuss the divisors of 11 and of number 11, we see that it is only divisible by 1 and itself, which is 11. This means that 11 is a prime number. So now we would like to write a program to check if a number is a prime or not using a Boolean flag. To do that, we wrote a code here, but before doing anything, let me run the code first and see how it works. Then we are going to analyze the code step by step. So when I run, it asks me to enter a number. I say 15. It says that 15 is not a prime number. Let me run again. I say 20. It says 20 is not a prime number. I say 11. 11 is a prime number. So basically, we have a program that is asking the user to enter a number, and the number is stored somewhere in the memory. Then it checks to see if the entered number is actually a prime number or not. So to do that, we have one main function here and another function to check the number to see if it's prime or not. So in the int main function, we're basically having, for example, an integer called number that is declared here. And then we are asking the user to enter a number using cout. And then using cin, we are storing whatever the user is entering in the number. Okay? Then we are having one condition here. So the if else condition here is checking to see if the number is prime, go and do this action, and otherwise, meaning that if it's not a prime, go and do this action. Okay? But how is it checking to see if the number is prime or not? To see that, it is calling a function called isPrime and passing number as the argument. So when we go up, we see that we have a function here called isPrime. It is of Boolean type. It means that it returns a Boolean, either true or false. It is going to return. And the argument is of integer type. So basically, when we are having this condition in the parentheses, it means that either the result of this function is true or false, because it is going to return either true or false because it's of Boolean type. If it says that it's true, it means that this condition is true and this action is going to be performed, saying that the entered number is a prime number. And if it returns false here, this condition is not going to pass and it is going to enter the else part, and it is going to print that the entered number is not a prime. But let's check and see how we are checking to find out if a number is prime or not. To do that, we are initializing one boolean called prime flag, and by default it is set to true. And in order to check and see if the entered number is divisible by other numbers or not, we are going to write a for loop starting from 2, because for sure any number is divisible by 1. So we are going to start from 2, and we are going to continue as long as I is lower than the entered number by the user, which is num here. And when we are going to iterate over all the numbers from 2 until we reach the entered number, until we are lower than the entered number, we are going to check if that number that the user entered is divided by I, which is our initialized number here starting from 2, and its remainder equals 0. It means that it is divisible by a number, okay? And if this happened, just put the false to the prime flag here, which was by default true, and break, meaning that get out of this loop and return the value of prime flag. So let me just make an example here. So we entered the number 11. So the user entered number 11. So number equals 11 here, okay? And we are checking here in this if condition, we are checking if is prime 11, because we are passing this number as the argument of the is prime function. And when we are calling the function like this, using this line, we're calling the function like this to check if this function with this argument is going to return a true value for us or a false value. By default, it is true, and it checks to see if in certain conditions it becomes false or not. But let's go up and see. So the user entered 11. So here num equals 11, and I is going to start from 2, and it is going to be 3, 4, 5, etc. until 10. Why not 11? Because 11 is not lower than 11. So the maximum number that the I can get is 10, because 10 is lower than 11. Okay, so we are going to iterate from 2 to 10 for different values of I and check if 11 is going to be divided by 2 and its remainder equals 0 or not. So in the first iteration, for example, when I equals 1 equals 2 and num equals 11, we are basically in this if condition here, in this part, we are basically saying that 11, if 11 is divided by 2 and its remainder equals 0, then if this is true and if this happen, just put the prime flag set to be false and then break, okay? And then break. But we know that if 11 is divided by 2, its remainder is not going to be equal to 0. Therefore, it is not going to enter this condition, this part. So it is going to it is not going to enter this part, so it is going to go up again and increase the value of I by one value. So I now equals 3. I equals 3, and it says num is, it is a fixed number, so it is 11. So we are checking to see if 11 divided by 3 equals 0. It means that prime flag has to be set to false and then break. Okay, then break. But we know that if 11 is divided by 3, its remainder is not going to be equal to 0. Therefore, this condition is not passed. Therefore, it is not going to enter this if condition, and it is going to go up again and increase the value of I. So in the next iteration, I equals 4, and it is going to continue until I equals 10. And in neither of these situations, 11 is not divisible by any of these numbers because 11 is a prime number. So this is why it is not going to enter this if condition in any case. So we make sure that 11 is a prime number, and when we found out that it's a prime number, it is going to, in the end of the function, when I equals 10, the last check will be if 11 divided by 10, its remainder equals 0, and this is the last time that it enters this for loop, and it is going to check this if condition here. So in this part, it is going to not enter this if condition again because this part is not true, so it is not going to enter this part, and this for loop is also finished, and by default the prime flag was set to be true, so it is going to return prime flag, which is true, and therefore when that part is going to return true, this part will become true, and this if condition is true now, and we are going to enter this part of the code, which means that we are going to enter that 11 is a prime number. However, if we, for example, number 20 here, the user enters 20, so imagine that it is 20, and I is going to start from 0 and goes up until 20, 19. And when we are having different, like when I equals 2, it means that, okay, I equals 2, we have the number 20. So 20, if it is divided by 2, and its remainder equals 0, which is true because 20 divided by 2, the result is 10 and the remainder is 0. So set the prime flag in this line to be false and then break. It means that we found one divisor for the number 20 that is neither itself nor the number 1. So break because it is not a prime number. So it is going to set false here. It is going to get out of this and out of this part. Okay, out of this part, sorry, out of this part, and then it goes to check again, and when it is set to false, it is going to return the false value here, and when it is going to return the false value here, this part is not going to pass because it is going to pass only if it's true, and when it's not true, it is going to enter this part, and it is going to mention that, okay, this number is not a prime number. So let me explain it one more time. So if the number is like, let me enter another number. So if the user enters number, for example, 10, number equals 10. If the user enters 10 and it is 10 here, and number is 10, for example, now, so I is going to start from 2 and it is going to go up until 9, and when 10 is divided by 2 in the first round of this for loop iteration, its remainder is going to be equal to 0. So it means that this condition is passed, so it is going to enter this part, and when it enters this part, it is going to set false to the prime flag. When it is setting false to the prime flag, it is going to break, and it is going to return the false value for us. Why? Because we found a divisor for our entered number, and the divisor is neither 1 nor the number itself, meaning that it's not a prime number. So this is basically how we're going to understand it through this block of code. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program that converts a temperature from Celsius to Fahrenheit or vice versa. So let me first run the code and see how it works, and then we're going to dive deep into the details. So when I compile, it shows me this message saying that temperature converter. First, Celsius to Fahrenheit, to Fahrenheit to Celsius. Enter your choice. So if I enter 1, it means that I'm going to give a Celsius number, a Celsius degree, and get in the end, in the result, its equivalent in Fahrenheit. And if I'm going to enter number 2, it means that I'm going to give a number that is in Fahrenheit, and then I'm going to get in the end from the program the Celsius value. So I'm going to first click 1. So it says enter temperature in Celsius. I would say 180, and when I enter, it says temperature in Fahrenheit, so its equivalent in Fahrenheit is 356. And when I compile again, now I'm going to choose number 2, and it says enter temperature in Fahrenheit, and I'm going to enter, for example, 300. It is going to give me its equivalent in Celsius, which is approximately 148. So we would like to write a program that converts Celsius to Fahrenheit and vice versa. To do that, we have two functions here to do the this conversion for us. Here, these are basically the formulas that you can find on internet. And one main function that I have here I'm going to declare one integer and one double that are called choice and temperature respectively. So the choice will be integer because it's the number that the user is going to enter, either 1 or 2. But the temperature is a double because you may want to enter, for example, the equivalent of Fahrenheit of 185.42 in Celsius is what number? So because it may have some decimals, we're considering a double number here. And then we are asking the user temperature converter. This is the title. And then we are mentioning that with \n we are going to next line, and the first option is Celsius to Fahrenheit, then \n next line again, and then Fahrenheit to Celsius, \n, and again it goes to the next line and it says enter your choice. And whatever the user is going to enter is going to be stored in the integer choice using cin keyword. And then we are going to check the user entered what. So if the user entered 1, do this part. If the user entered 2, do this part, and we need to write else if because it's another if condition. And otherwise, if the user entered any other number than 1 and 2, just do this part. So if the user enters any number other than 1 and 2, we are going to show this to the user that it's an invalid choice because we asked either 1 or 2. So if the user is going to choose number 1, we are mentioning that again, enter temperature in Celsius. And whatever the user is going to enter is going to be stored in the temperature double. And then we are going to just print out in the terminal saying that temperature in Fahrenheit, so or the equivalent in Fahrenheit, is and then we are going to call the function that is called Celsius to Fahrenheit, and we are going to pass the temperature argument to this function here. So this function name is Celsius to Fahrenheit. It's of double, so it is going to return a double value for us, and its argument is also a double. So what it does, that is, it is going to do some mathematical operations here, and it is going to return the output. Basically, this is the formula of converting a Celsius number or a Celsius degree to a Fahrenheit number or a Fahrenheit degree. Basically, we have the Celsius degree here multiplied by 9 divided by 5 in parentheses, and the result of this parenthesis is going to be added to number 32. And then when this calculation is done, it is going to return the resulting value here, and it is going to show it in the output. Okay, so and if the user choice was equal to 2, we are going to again show this part to the user saying that enter temperature in Fahrenheit, and we are going to, whatever the user is going to enter is going to be entered to be stored in the temperature here. And then we are saying that, okay, you wanted to convert from Fahrenheit to Celsius. We are saying that your temperature in Celsius, or its equivalent in Celsius, is, and then we are going to call this function with the temperature argument, and this function is Fahrenheit to Celsius. This is the other function. It's of the type double, so it is also going to return a double value for us, and it is going to accept one argument that is doubled here. Basically, it is going to return this part. So after doing the mathematical operations over this part, it is going to return the resulting value. And the formula is like the Fahrenheit degree minus 32. It is going to be multiplied by 5 divided by 9. And when it is doing the calculation, it is going to return the value basically here, and that's it. So let me recompile again. So it says we are here now, enter temperature converter, we have \n, it goes to next line, Celsius to Fahrenheit, Fahrenheit to Celsius. I'm going to choose 1, and when I choose 1, it is going to enter only this part of the condition. So this part, it is going to show the message saying that enter temperature in Celsius. When I enter, for example, 180, it is going to store my number into the temperature double here. And then it is going to, when I enter, it says temperature in Fahrenheit, which is here. And then it is going to call the function Celsius to Fahrenheit, and pass the temperature number here. So what I entered as a temperature is going to be now double Celsius here. So the Celsius, the entered number, times this number, and then the whole parentheses output is going to be added to 32, and the result will be 356, which is going to be returned by this function and shown exactly here. So if I choose number 2, it is going to enter this part of the loop as we tried once, and if I, for example, enter number 5, it is going to say invalid choice, because we only had the condition if it was equal to 1 or it was equal to 2. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to generate the first n numbers in the Fibonacci series. So let me just run the code first to see how the code works and talk about what the Fibonacci series is, and then we're going to dive into the details. So when I run, it asks to enter the number of terms. I'm just going to type down, for example, 7, and it is going to print out the 7 terms of the Fibonacci series. So the first 2 terms in the Fibonacci series is always 0 and 1. And then the third term is computed based on the summation of the first 2 ones. So 0 plus 1 is 1. Then 2 is calculated to be 1 plus 1. Then 3 is calculated to be 1 plus 2. Then 5 is calculated to be 2 plus 3. And 8 is calculated to be 3 plus 5. So any term in Fibonacci series is going to be calculated based on the summation of the 2 previous terms before that number, except for the first 2 ones that are constant. And so basically the program was asking the number of terms. So we mentioned 7, and then it prints the 7 term of this series for us. But how do we do it? So we would like to write a program to generate the first n numbers in the Fibonacci series. To do that, we have one main function and another function that does the mathematical operations part of the work for us. Initially, we're going to declare one integer called n. We're asking the user to enter the number of terms, and we're storing the number that the user is telling us. We are then printing out, okay, if the number that you entered is lower than 1, it's an invalid input. Number must be greater than 0. And then we are saying that, okay, if the number was larger than 1, so it was larger or equal to 1, it is going to call the print Fibonacci function, and it is going to pass the argument, which is the entered number by the user, which is n, to the function. So the name of the function is print Fibonacci. It's a void type, so it is not returning anything. It is just doing some mathematical formulation for us, and it may be printing some stuff for us. And then the argument is of integer type. Here we are initializing int a and b. So a equals 0 and b equals 1, and they are the first 2 terms in the Fibonacci series. As I showed you before, the first 2 terms are 0 and 1, so we are declaring the first 2 terms, and based on them we are going to create the following terms, and we are declaring one integer called next that is going to compute the next term for us. Then we are going to print out Fibonacci series, and a and b are printed here, 0 and 1 are printed directly here. After that, we're going to start a for loop. So the loop is going to start from I equals 3, and this loop is going to continue as long as I is lower than or equal n, and n is the input number of the user. So I, for example, if the user enters 8, I starts from 3 and is going to continue until I equals 8. For every iteration, we are going to implement this part, and we are starting from 3 because the first 2 terms that are 0 and 1 are already printed here. So this is why we're starting from 3. So the first 2 terms, let me just explain with an example here. So if I have the n equal 8, I initially equals 0, and also b equals 1. Okay, and in the first iteration I equals 3. So let me have them all in one line. It would be, I think, easier. So then I equals 3. Okay, so in the first iteration we calculate next. The next was declared here, but it was not initialized. So a plus b will be set will be assigned to next. So next is a plus b. It means that 0 plus 1. It means that next equals 1. And then we are printing out the next value and then 1 space. So it means that initially we printed out this part. So we printed out this part. We had this part. So A and B were already printed, meaning that 0 and 1 as the Fibonacci series terms, they were already printed here. Okay. And then we calculated the next to be A plus B, which is 0 plus 1. And we printed out next using this line with and then 1 space afterwards. So therefore next is printed here. After that, after next is printed here, we are assigning B to A. So now B equals 1. When we are assigning B to A, means that it means that A now equals to 1. And then next is assigned to B. Next was also 1, so B is now 1. We did this line of code because if we want to calculate the fourth term here, we have the first term, second term, the first term, second term, and the third term here. And when we want to calculate the fourth term, we need to know the amount of A plus B. And A plus B is now 1 and 1. Previously, A was 0 and B was 1. Now A is 0 and B is 1. Why? Because B was 1 and assigned to be to A. And the value of next, which was already 1, we calculated here, is assigned to B. So now, instead of having A equals 0 and B equals 1, we're having A equals 1 and B equals 1. Okay? After that, we are going up again, and I is increased to be 4. Now that I equals 4, we are calculating the next again. So next equals A plus B in this line. It means that A is 1 and B is 1. So now next equals 2. We calculate the next here, and then we are going to print out this line, which is going to be the next term. And now next is 2. So 2 is now printed here. And then we are again assigning B to A. So B is 1 and we are assigning it to A. So A still equals 1. And then we are assigning next to B. So B is 2 and next is 2 and B was 1. So when next is assigned to B, B equals 2. So we did that. Why? Because in the next iteration, we need to calculate the next term, and the next term is calculated as the summation of A and B. So now A is 1 and B is 2, so we can calculate the next term of the Fibonacci series. So then I equals 5. Because we go up again and we increase the I. So I equals 5. We enter this for loop one more time. So next equals A plus B. It means that 1 plus 2, because A is 1 and B is 2. So A is 1 and B is 2. We are going to calculate the next term. So it means that next equals 3. And when we understand that next is, we calculate the next, we are going to print out the next here. So this term will be 3 now. And then we are going to reassign A and B. So the value of B is assigned to A. The value of B was 2 is assigned to A. So A is moving one place forward. So now A is 2. And then next is assigned to B. So next was 3 and now B is 3. Again, we are doing this because we would like to keep track of the summation of the last two terms in order to calculate the next term in the Fibonacci series. So when we do that, this loop is finished. This iteration of the loop is finished. We go up again and I equals 6 now. So we have next equals A plus B. It means that we are having 2 plus 3 because we have 2 here and 3 here. And we are having next equals 5. When we are calculating the next, we are going to print the next in this line. So the next one is 5, which makes sense because 2 plus 3 is 5. Then we are going to reassign A to be B. So B was 3 and now it is assigned to A. So A is 3 now and B equals 5. So equals next. So next is 5. 5 is assigned to B. And then we go for the next iteration. I equals 7. We are having next equals A plus B equals 3 plus 5. It means that next equals 8. It means that here the next one is 8. Then we are printing out the next here, which is 8 here, and then we are reassigning A and B. So A is the previous B here is B, and then B equals 8. So after doing that, I equals 8 because we mentioned that if the user entered to print out the first, for example, 8 terms of the Fibonacci series. So next equals A plus B, meaning that 5 plus 8, we know it from the previous line. Then next equals 8 plus 5, it means it is 13 now, for example. And then we are reassigning A and B. Before that, we are printing 13 here. And then we are reassigning A and B. So B is assigned to A. So whatever the value of B was is now is assigned to A. So A equals 8 and B equals 13 because next is assigned to B and next is 13 and it is assigned to B. So B is 13 now. And then this loop is finished. It was the last iteration because I was equal to 8 and it was supposed to repeat this for loop as long as I is lower than or equal to n, and n was 8. We assume that the user entered number 8. So I equals 8. This is the last time we entered this for loop, and then in the next iteration, because I is increased by one value, so I equals 9, and 9 is not lower than or equal to n, which is 8. Therefore, this condition is not passed, and then this loop is not executed. After that, we are simply just having the handle keyword here, which gives the function, the syntax, the command to go to the next line, and that's it. So this is how we are printing out the terms in the Fibonacci. So here, if I run the code one more time, you see that it says enter the number of terms. I would say 8. And when we say 8, 8, is it lower than 1? No. So it is going to go to the else part. It is going to call the print Fibonacci function and pass the n argument. And n is the 8 number that we entered here. Because whatever we enter, it is going to be stored in n. When we do that, first a and b is printed. So 0 and 1 is first printed out. Then it enters the loop, it does the calculation, and one by one it prints all the terms of the Fibonacci series until we reach the 8th term, and then it stops there. So as you see here, we're having the same Fibonacci series here and there because we did the correct calculation. Thank you for watching. Hello everyone, welcome to another lecture. In this lecture, we are going to write a program that calculates the average grade of a student from 3 test scores and determines the final grade. In order to do that, we are going to declare 4 variables of float type. The first 3 variables are the ones that we are going to store the score from the user, and the fourth one, which is average, we are going to calculate the average among the first 3. So we show the message to the user saying that enter the grades for 3 tests, and we are storing the data that the user is entering as to be test 1, test 2, and test 3 scores. When we have the 3 scores from the user, we're going to calculate the average using this formula. So we are having the summation of test 1, test 2, and test 3 divided by 3. Based on this, we can calculate the average. And we are simply just showing the average in the output. And based on the output of the average, we can have different output as well. For example, if the average is larger than 90, larger than or equal to 90, we can have the grade A. If average is between 80 and 90, we are going to have grade B. If it is between 70 and 80, it is grade C. If it is between 60 and 70, it is grade D. And if it's any other number, it is going to show grade F. So let me run the code once. So it says enter grades for 3 tests. So I would say 95, 80. Oops, sorry. I made a mistake. So let me run again. 95, 80, 75. So it says the average grade is 83. So, and the final grade is B. So here, when I run the code, the first line is this line. So it says enter the grade for 3 tests. So this is the line. So then I started entering 95, 80, and 75. And these 3 numbers basically are stored in test 1, test 2, and test 3 respectively. Then with this code, we are calculating the average of these 3 numbers. And after that, we are having the message average grade. So cout average grade. And this is the average grade. And it is printed out here, the calculated average, which is 83. So depending on the number of the average, we can have different output, further output as well. So using this if-else condition, we show that the average, if it's between 80 and 90, the final grade is B. So in our case, it is approximately 83. So the final grade is B because 83 falls in this condition because it is between 80 and 90. So let me run the code one more time. So if we have, for example, 90, 92, and 95, now it says the average is 92 and the final grade is A. And the reason why is that because the average is 92, so it is larger than 90, so we're going to have the final grade A. So using this exercise, we reviewed the if-else conditions here, so how the output would be different if the conditions are different. And also we reviewed how to do one mathematical operations here and how to read and store data entered by the user from the terminal. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to create a simple calculator that performs addition, subtraction, multiplication, and division using a switch statement. To do that, we have a function that does these per mathematical operations and performs these operations for us. And then we are having one main function that we're calling the other function that does the work for us. Initially, we declare two double numbers, num1 and num2, and we are also declaring one character called OP. So we ask the user to enter the first number, and we store the first number. We ask the user to enter the second number, then we store the second number. Then we are asking the user to enter an operator, meaning that they can have the addition, the subtraction, multiplication, or the division here, and we are storing it whatever the user is mentioning. But please note that the first two, because they were numbers, we stored them in double, but the last one we are storing them in OP, which is a character, because it's a character and it's not a number. Okay, so and then we are declaring and initializing a result double that is going to call the calculate function and pass three arguments. So the first number, the second number, and the character that the user entered. By these three arguments, we're calling the function, and then the function is going to do the calculation for us, set the result into result. So calculate and obtain the output and put it to result, and then we are going to print out the result. So let me run the code, and then we are going to analyze the code one by one. So enter the first number, I would say 2. Enter the second number, I would say 5. And enter an operator, I would say plus or addition. So it says result 7. So if I have like 20, the second number is 10. And if I choose division, it is going to give me the result of 2. So when we call the function, you see, let me rerun one more time. So enter the first number, we are here, I would say 20. Then enter the second number, then this part of the code is executed, I would say like 2. And then enter an operator, I would say like subtraction. And then when I enter the subtraction, it is storing it in OP. And then it is calling the calculate function. It does everything, and it is going to print out result. And then this is printed out, which is 18 here. Okay, so when we call this function name is calculate, and it's of double type, so it is going to return a double for us. So as you see, we see the return here. And then it has three arguments, each is separated by a comma. So the first two are double, and the last one is a character. Then the program asked us to do all of these mathematical operations using a switch statement. We could do it with if-else condition, but they explicitly mentioned to use switch statement. To do that, we have the switch keyword, and then we are going to perform the condition over the character that the user is going to enter. So addition, subtraction, multiplication, or division. Then when the variable is there in the parentheses, in the brackets, we're going to type down in this part the conditions. So the first case, if the user enters addition, return a plus b. So a plus b, the first argument plus the second argument. If the user enters subtraction, return a minus b. If in case the user enters star, return a multiplied by b. And then if the user entered division, first we need to check to see if b is not equal to 0. This part is the condition part, is not equal to 0. This question mark is going to separate the condition from the potential output. Okay, so on the left hand side we have the condition, and on the right hand side we are having the potential answers, potential output, and outputs are separated with colon. So this is first potential output, this is the second potential output. So it says that return something, but before we know that what that something is, we need to check this condition. So if b does not equal 0, return a divided by b, otherwise return 0, because if b equals 0, we cannot do the division. This is why we need to check this condition. So if b does not equal to 0, we are going to return the a plus b, the first potential output, which is separated by a colon here. Otherwise, if b equals 0, we are going to return 0. It means that, for example, if the first number is 20 and the second number is 10, 10 is b, and b now b is 10, so 10 is not equal 0, so a divided by b is going to be returned in the output. However, if we are going to enter like the first number is 20 and the second number is 0, it is going to return 0 because it does not pass this condition, because it says b does not equal 0, but we entered the second number to be 0, so it is going to return 0 because it's not possible to divide the number by 0. So this is basically how this works. So when I recompile, I enter the first number 20, I enter the second number 10, and then when I choose the divide, it passes everything to this function and checks the OP, the third argument, which is here. And the OP in our case was a division, so it came here, it checked the condition. So the B, or the second number, was 10, so 10 is not equal to 0, is not equal to 0. So yes, this is true, 10 is not equal to 0, then it is going to do the a divided by b and returning 2 for us. So 20 is divided by 10, it is going to return 2 for us. So this is basically how we can write a function that that works like a simple calculator using a switch statement. Thank you for watching. Hello everyone, welcome back. In this lecture, we would like to write a program to generate and display the multiplication table for a given number. So in order to write a program like that, we need to have a function that does the work for us and have a main function as always. So we are declaring one integer number called number. Then we are printing out to the user saying that enter a number. Then we are reading the number and storing the number from the user. Then we are simply calling the function and we are passing the argument number that was entered by the user to this function. So this function name is print multiplication table. It's of void type, so it's not going to return any value for us. It may does some calculation or doing some prints for us, but it is not going to return any value. And the argument of this function is integer. So basically this function is going to have a for loop starting from I equals to 1, and it is going to continue as long as I is lower than or equal 10. So it is going to print all the multiplication table of a number for us. Basically, we are saying that, okay, cout and then num, which is the entered number by the user, and this is the argument of this function, is printed. Then a multiplication sign is printed because it's in quote. It's in quote, you see. And then I is printed in the, for example, first round, I equals 1, then equal, then num multiplied by I is printed. So if I want to explain it better, so num is, for example, if the user enters number 5, okay, 5 times, or x, let's say, 1, because I in the first iteration equals 1, I start from 1, equals, then the result of 5 times 1 is printed here, which is 5. Then we have endl, so it goes to next line. Then we have 5 times 2, because in the next iteration I equals 2, equals 10. And then we have 5 times 3 equals 15. Okay, and it is going to continue until I equals 10. When I equals 10, we are having the last row being printed. 5 times 10 equals 50. So basically, this is how we are going to print a multiplication table. So let me run. When I enter 5, it is going to give me a multiplication table of number 5. So basically, it says enter a number, I enter one number, and it is going to store that number. Then it is going to call the function. So when it calls the function starts from 1, as you see here, and it goes until 10. Okay, and in each iteration, 5 is multiplied by the number of I, and then the result is written here. So 5 is multiplied by the number of I, and the result is written here. Okay, so 5 times 1, as we mentioned here, 5, 5 times 2, 10, 5 times 3, 15, we have it here, and it continues until the last row is 5 times 10, which is 50. Basically, this is how we can write a program to generate and display the multiplication table for any given number. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to track the balance of a bank account by tracking an initial amount and allowing a deposit and withdrawals. In order to do that, first we are declaring 3 variables. They're called balance, deposit, and then withdrawal. So firstly, we are going to ask the user enter initial balance, and then it is stored in balance. And then when we know the balance, the initial money in the bank account, we're going to ask the user enter the deposit money. So if the user would like to deposit some money, they can do that using this line. So we show the message to the user, and we are storing whatever that they are entering, and then we are adding this deposit to the initial balance of the bank account. So this line means balance plus deposit. So this line is the equivalent of this line. It means that whatever the new balance is, whatever that is already in balance plus the deposit. And also then we are showing that if the user, for example, would like to withdraw some amount of money, they can do that. We're having the cin keyword in C++ to store what the user is entering. And then we are having the withdrawal money reduced and subtracted from the original balance. So here this line also means balance equals balance minus withdrawal. And finally, we are showing the final balance of the bank account to the user. So let me run the code first, and we will also analyze the code afterwards. So when I run the code, so we are here, enter initial balance. So I would say the initial balance is 0, for example, and I would like to deposit some money in my bank account. So I would say like $500, for example. And here it was the $500. And then here it says enter a withdrawal amount. So I would say I would like to withdraw $100 and the final balance is 400. So basically with this code, we can have the initial balance, we can have the deposit of money, and we can have the withdrawal of money, and we calculate the balance of the bank account accordingly. In order to have another example, I would say, for example, the initial balance is 150. I'm going to deposit 50 and I'm going to withdraw, for example, 200, and it says the balance is 0. Why? Because the initial balance was 150. We deposit some money like $50 and total balance is now 200, and then I'm going to withdraw all the 200, so the final balance is 0. So we can also have like I have 100 initial balance, I'm going to deposit 200, and I'm going to withdraw 0, for example. I'm not going to withdraw any money. So the final balance is 300. We see that even with very um, easy and simple examples, we have a practical code here that can resemble the real situation in the world. So basically the bank accounts are working exactly like this simple part of code. So you can see the practicability of these examples that can happen in the real world. Thank you for watching.
Hello everyone, welcome back. In this lecture, we would like to write a program to calculate the body mass index or BMI for a user. To do that, we have one main function and another side function that does the calculation for us. So in the main function, we are declaring two double numbers that are weight and height. We are telling the user enter your weight in kilogram, and then we are storing the entered number by the user. And we are asking the user to tell your height in meter, and then we are going to store it. And then we are going to declare another double called BMI, and we are going to call the calculate BMI function, which is this function, and we are going to pass two arguments, the weight and the height that were read from the user. So basically the result of this function is assigned to BMI, and then we are printing out the BMI. So basically this function name is calculate BMI, so it's of double type, so it is going to return a double value for us. And there are two arguments in the parentheses for this function, and they are separated by a comma. The first one is weight and the second one is double. So basically this function is going to return the result of this equation. Weight is divided by height times height. So this is how we can calculate the BMI based on the weight and the height of a user. So when it is calculated, it is going to assign the result in this double, and then we are going to print out this double here. Okay, so let me run. If I run the code, it says that enter your weight. I would say, for example, 90 kilograms. Enter your height. For example, I could say 1.82. It says that, okay, your BMI is 27.1706. We could write another one. For example, I could say enter your weight. I would say 100. And then the height, we could say, for example, 1.6. It means that your BMI is around 39, so it's a pretty much high number. So this is basically how we can calculate the BMI given the weight and the height of a user. Thank you for watching.
Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to check and see whether a number is odd or even. In order to understand if a number is odd or even, we need to know if the number is divided by 2, its remainder equals 0 or not. So if its remainder equals 0, it means that it's an even number. Otherwise, it's an odd number. For example, if we divide 10 by 2, the remainder will be 0. Okay, so the result of 10 divided by 2 is 5, and 5 times 2 equals 10. It means that the remainder equals 0. Remainder equals 0. However, if we divide, for example, 11 by 2, the result would be 5 point something. And for example, this 5, if it's multiplied by 2, it will be 10. It's not going to be 11. So it is going to have some remainder, some value. Okay. So it means that number 11 is not an even number. So if we do it for all the even numbers, it makes sense, this rule. So 20 divided by 2, the result would be 10. So 10 times 2 will be 20, meaning that it has no remainder. So remainder equals 0. Or if we do another exercise, for example, if we divide number 13 by 2, the output would be, for example, 6. But if the 6 it is multiplied by 2, the result would be 12 and not 13. So remainder is not equal 0, meaning that 13 is an odd number. Okay, we do this checking also in the code. So we are first declaring one number, and then we are asking the user to enter one number, and we are storing the number, and that number is divided by 2, and we are checking to see number modulo 2. It means that when we are using a modulo sign, means that if the number is divided by 2, its remainder equals 0. If we would like to check the division number, we are going to have this sign, but modulo means that if the number is divided by 2 and its remainder equals 0. This condition in the parentheses is discussing exactly this sentence that I mentioned. And then we are printing out if this makes sense, if this condition is passed, because the remainder of the number divided by 2 equals 0, it means that the number is even. So we are going to print out number and then is even. Otherwise, it is odd. So let me run the code. Enter a number. I would say 20. It says 20 is even because we are saying enter a number here exactly in this line and storing 20. Then it is dividing 20 by 2, and when 2 and 20 is divided by 2, the output is 10. So 10 multiplied by 2 will be exactly 20. So the remainder equals 0. Basically, this is why when the remainder equals 0, it enters this parenthesis condition is passed, and it enters this part, and it is going to mention that 20 is even. So if I enter 13, it says 13 is odd. Why? Because when 13 is divided by 2, its remainder does not equal 0. So it does not pass this condition in the parentheses, and it will enter this part. So it says 13 is an odd number. And also, just for your information, let me print out some part here. So let me just comment this part. So for example, if we have this code, for example, we have int a equals 20, we have int b equals 2, for example, and we are going to see out a divided by b and l. So when I run this code, you will see the output is 10. So a divided by b, 20 divided by 2, the output is 10. Okay, but when I have the modulo sign and I run, it says 0. So A divided by B, its remainder is 0. When you're using the modulo sign, it is going to show you the remainder of the division. Okay, so here is happen the same thing is happening. So it is showing the remainder of this division. Does the remainder equal 0? If yes, this condition is passed and this line of code is executed. Thank you for watching. Hello everyone, and welcome to another lecture. In today's lecture, we would like to write a program to count the number of words in a sentence entered by the user. In order to do that, we ask the user to enter a sentence, and then we are iterating over the sentence components, and then we are printing out the number of words. So let me run the code first, and then we dive into the details. So when I run the code, I would say this is Reza Shahin, and I enter. It says number of words 4. So 1, 2, 3, 4. So when I run again, this is C++ practice, I would say project lecture. So when I enter, it says 5. So 1, 2, 3, 4, 5. But how does it work? Firstly, we are initializing one string, and then we are initializing one integer called word count equal to 1. Then we are asking the user to enter a sentence. However, we are reading the sentence using this line of code. Previously, we learned that we can read, for example, we can cout, enter your, for example, number, and then we had cin to, for example, store the data int a, okay? Previously, we were using this keyword to store anything. But using getLine means that when we have more than one word, we must use getLine because cin cannot understand more than one word. For example, if I have string a, enter your sentence. So let me just comment this part. I'm going to say enter your sentence, and I'm going to read the sentence and store the sentence using only cin. So when I cout a and l, you will see that the result is not what we would like to have. So let me run. So enter your sentence. I would say this is Reza, and it is only returning the first part. So using cin is not very good for a sentence because it is going to understand the first part, and when you have a space, it simply stops and it does not go further. So this is why in our code here, we are using the getLine keyword to store a sentence. In order to have a sentence being stored, we need to have the getLine syntax, and then within the parentheses we have two arguments separated by a comma. The first part is always the cin, and the second part is the string, for example, that we would like to store whatever the user enters in. So we initialize the sentence here as a string, and then we are storing everything in the sentence here when we are putting it as the second argument. And then we are having one for loop here that the character C is going to iterate over the sentence string, and if C in the meantime equals any space, it is going to increment the value of the word count, which is already initialized to 1, and then it is going to print out the output. So let me run the code one more time. I would say this is Reza Shahin. It says number of words 4. So 1, 2, 3, 4. It is correct. So why we are starting from 1? Because any sentence would have at least one word. So we start from 1. And then while we are iterating over the, when we are iterating over the sentence string, which is this is Reza Shahin, we are going to increment the value of this word count one by one if in the iteration we see any space. Okay, so we start from here, and when we start from here, we are already having the word count equal to 1. Then we are seeing this space, we are saying 2. Then we see this space, then we are saying 3 words, and then we see that this space exists also, so we are saying we have 4 words. Basically, any space is counted as to be a word here, because between any words we are going to have a space already. So we have one word initialized, like here, and then any space that we see, we increment the value to understand how many words do we have. This is the policy to count the number of words. So I will explain one more time. So we are initializing word count as to be 1, because in any sentence we are going to have at least one word. Okay, so it is equal to 1, and then we are iterating over this string, this sentence, and any space in this sentence is making the word count to be incremented by 1. So initially it is 1. It sees the first space, meaning that we are having a space to separate a word from another. Okay, so this is why when we see a space, we are incrementing the word count. So initially it was 1, now it is 2 because it saw this space. Then it saw this space, so it is 3 now, and then it saw this space, so it is 4 now. So any space is counted to be number of words here. And how do we check that? We are having a for loop here. A character C is iterating over the string sentence, and if C equals a space, it is going to increment the value of word count by 1 value. Thank you for watching. Hello everyone. We would like to write a program to calculate the power of a number. For example, if 3 to the power of 2 means that 3 times 3 equals 9, or 2 to the power of 3 means 2 times 2 times 2, which equals 8, for example. To calculate this in C++, we can use one library function called POW, or POW. And in order to use that, we need to include the header called CMath. To do that, we are asking the base number and the EXP, which is the power of the number. And then we are having the message showing to the user saying that enter the base and exponent. So the base and exponent is mentioned, and then we're simply printing out the result using this part. So in this function POW, or we have POW, we can have two arguments. The first argument is the base argument, and the second argument is the exponent argument. For example, when we would like to calculate 3 to the power of 2, which is 9, we need to have something like this: POW 3 and 2. Okay, when we are going to have, for example, 5 to the power of, for example, 6, we can have POW 5 and 6. Okay, so the left side is the base number, and the right side is the exponent. Okay, and basically it is going to do all the calculation for us. It is an already predefined function in C++, so it made our life much easier. So let me run the code. So when I run the code, it says enter base and exponent. I would say the base is 5, the exponent is, for example, 2. It is going to give us 25, which is the result of 5 times 5. So if I say, for example, 5 and 3, it is going to return 125. Basically, using the library function POW, we can calculate a number to when a number is going to a power of another number. So for example, to calculate the power of a number. Thank you for watching. Hello everyone, welcome back. In today's lecture, we would like to write a program that calculates the age of a person based on their birth year. To do that, we first declare three integers: birth year, current year, and the age. Then we are asking the user, give us the birth year of yours, then give us the current year, and then calculate the age. So age will be equal to current year minus the birth year, and we are simply showing the result in the output. So let me run. So it says, enter your birth year, I would say 1992. Enter the current year, we are in 2024. For example, it says your age is 32. Let me just have one C out and del here, so it will be nicer. So enter your birth year 1992, current year 2024. So your age is 32. So when I added this ndl, this part went to the next line, so it is easier to read the output for us, the last line of the output. So your age is 32. Basically, using this code, we can calculate the year of the current age based on the birth year and the current year. Thank you. Hello everyone, welcome to another lecture. We would like to write a program to convert an amount between currencies using a fixed exchange rate. To do that, first I run the code. So it says enter amount in US dollar, I would say 200. And it says amount in euro is 170. So in order to have this part in the next line, I'm going to add one cout ndl. So cout ndl. Okay, so when I say, for example, 200 USD, it says the amount in euro is 170. To do that, we declare two doubles, that is the amount and the converted amount, and we are having one fixed exchange rate, which is just an assumption here. It may not be the correct number here. It is just an assumption. You can check the current rate, basically in Google. So here I assume it is 0.85. Then we are asking the user to enter amount in US dollar. The user is going to enter it and we are going to store it. Then we are going to calculate the converted amount. So the converted amount is the amount multiplied by the exchange rate. So 200, for example, if I enter 200, 200 is going to be multiplied with 0.85. So the converted amount in euro, the equivalent in euro, is going to be stored here. And we are simply outing the amount in euro is whatever. So if I, for example, say 500 USD, it says it is 425 euros, the converted amount. So this is how basically we can use C++ to convert one currency to another. Thank you for watching. Hello everyone, welcome back. In today's lecture, we would like to write a program to swap two numbers using call by reference. In order to do that, we are going to declare two variables called x and y, and then we are going to ask the user to enter two numbers, and the numbers that the user is entering is stored in x and y. Then in order to perform the swapping operations, we are calling a function called swap, and we are passing as arguments x and y. So here, the name of the function is swap. It's a void type, so it's not going to return anything. And it has two arguments, the first one and the second one. Here, they are separated by a comma. And you see that both of them are of type integers. And we are having the call by reference. How do we know that? Because we are having the AND sign. When we are having the and sign in the arguments of a function, it means that this function is going to have access to the reference of these two variables, meaning that it can directly find the address in which these two variables are stored in memory, so it can directly make some changes into the values of these two variables. So we call the swap function and passing x and y, and we would like to simply swap them. In order to swap them, let me first run the code, then we are going to dive into the details. So enter two numbers. I would say 10 and 20. It says x is 10 and y is 20. Let me just enter one endl here. Cout endl, and let me just have this part here, enter x, so it is separated. It would be easier for you to understand. Then cin x, cout, enter y, endl, then cin y. So when I separate them, it's easier for you to follow what I'm teaching. So here we're saying enter x, I would say 10, enter y, I would say 20. And after swapping, it says x equals 20, y equals 10. So initially x was 10 and y was 20. Now x is 10 and y is x is 20 and y is 10. Okay, so we swap the values. To do that, let me just assume that x equals, let me just assume here, x equals 10, y equals 20 in the input. We know that in the input, as the input, the user is going to choose that. So therefore, initially, a equals 10 and b equals 20. Why? Because x is passed as the first argument, and the first argument here is a, therefore a equals 10, which is the value of x. Then y is passed as the second argument, and the second argument is b, so b equals the same value as y. So initially we have a equals 10, b equals 20. Then we are going to have one new variable called temp that we are declaring here, and we are assigning whatever that we have in a to be in temp, sorry. So now temp is 10 because we are assigning a to temp in this line. Then we are assigning b to a, so now a equals 20. So b is 20 and we are assigning b to a, meaning that a equals 20 because b was 20. And then we are having the b equals temp. So we are having the assignment of temp to b. So b equals 10 now. So basically we declared one new variable that is called temp here. We are setting a to temp and we are setting b to a, and then we are having temp to b. You see what I mean? Here we are setting 10 to temp, which is a. Then we are having b to a, which is 20 is set to a. And then the temp is assigned to b. So this way, the swapping is performed very easily. So we have a is going to be in temp, b is going to be in a, and temp is going to be in b. So basically we did the swapping exactly like that. So this is how the swapping is done. So when I run again, enter x, we are having x, enter y, we are having y, and it says after swapping we have x equals 20 and y equals 10. So here enter x, enter y. We are storing x and y, and then we are calling the swap function. So the swap function is called. We are doing the swapping here, and after that we are printing out after swapping exactly this line, x equals 20 and y equals 10. So this is basically how we can swap two variables using a call by reference. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to calculate the total cost of items in a shopping cart. To do that, first I run the code and then we're analyzing the details. So enter number of items. So I would like to say I bought 2 items. So the price for the first item was $10. The price for the second item was $12. And the program is going to return the total cost. So the total cost is 22. So basically we are asking the user how many items did you buy? Then enter each price of each product one by one, and then it will give us the total cost of our shopping cart. To do that, we have one integer called items, the number of items that we are willing to tell the program that we bought. Then we are having the price double and total double. So the total double is set to be 0 initially. Then we are asking the user enter the number of items that you mentioned that you bought. Then we are having a for loop starting from 1 and until I is equal to item. So the item is the number of items that the user bought. So in case that you bought 2 items, it is going to iterate in this loop 2 times. If you buy 3 items, it is going to iterate 3 times. Why? Because it is going to ask you the price. So when I enter 2 items, it is going to ask the price of item 1 and item 2. So, but if I mention that I bought 3 items, it is going to ask the item 1, item 2, and item 3. Okay, so basically here this loop is for the case when you're having different items, and it is going to ask you different price of each product. So if you buy 5 items, if you mention that you bought 5 items, it is going to show you this message, enter price item 5 times. Okay, so it is going to have a for loop. For example, if you bought 2 items starting from 1 and ends with 2, so it is going to enter price of item, for example, when I equals 1 and then I equals 2, so the item 1 and item 2. So in the first round, when I equals 1, it is saying enter price of item 1. Then you tell the price, and total equals total plus price. Then it is asking you enter the price of item 1 in this line. You're going to enter the price, so it is going to store it in the price double. Then this price double is added to the total. So this line of code is equivalent of this line of code. So the new total is the already total plus price. So already total was 0 and price was whatever that we entered here. So in case I mentioned that the price was 10, we're going to have 0 plus 10. So the total equals 10 now. And then when I equals 2, because I had 2 items, enter price of item 2. Then total equals total plus price. So total was already 10 plus the new price of product 2, for example, it is 12. So we are going to have the new total equal to 22. So using this code, we can simply calculate the total amount that we paid for buying like 2 items. For 3 items, it depends on the case and the instance, but this is how it works. Thank you for watching. Hello everyone, welcome to another lecture. We would like to write a program to create a mini quiz game with multiple choice questions. To do that, I would first run the code, then we dive into the details. So the question is, what is 2 plus 2? Option 1, 3, option 2, 4, and option 3, 5. So option 2 is my choice, so I would say 2. Then question 2, what is 3 multiplied by 3? Option 1, 6, option 2, 9, option 3, 12. So I'm going to choose option 2. My choice is option 2. And it says your score is 2 out of 2. So basically, we would like to design this mini quiz that is going to ask certain questions with multiple choices, and then we are going to give the answer, and it is going to calculate the score for us. To do that, we initialize two integer called answer and a score is set to be 0. Then we are showing this to the user. Question 1, what is 2 plus 2? And then we are having \n, which helps the compiler to go, which force the compilers to go to next line. Then we are having option 1, 3, then \n, which is going to next line. Then option 2 is 4, \n, next line. Option 3 is 5, and \n, next line. So when I mention next line is like this. When we are having option 1, which is 3, which is this part, and then \n means that the compiler is here now. When we are having \n, it goes to next line and starts writing from this line. So it is having the option 2, which is 4, and then after 4 we are having \n, which forces the user to go to option 3 to be printed in the next line. Okay, so then we are having this, and the user is going to answer. So the answer is stored using cin in the answer variable. And then we are saying if, because we know that the option 2 is the correct answer, if answer equals 2, meaning that if the user entered 2, we're going to increase the score by one value. So we're going to increment score. To do that, we simply do it score plus plus. Then we're having the question 2, what is 3 multiplied by 3? Option 1, 6, option 2, 9, option 3, 12. We're going to store the answer again, and if the user is going to choose option 2, which is the correct answer, we are going to increment the value of the score, which was initially set to 0. And finally, we are going to show the score. Your score is, and then score out of 2. So we are having the /2, meaning that we were having 2 questions, for example. So let me run again. So what is 2 plus 2? I would say option 1, which is not the correct answer. Then what is 3 times 3? I would say option 2. So it is going to say your score is 1 out of 2. So this /2 that you see there is exactly this /2 that you see here. And score is calculated based on the correct answer that is shown here. Okay, your score is, and then the score, and then /2. You see that you can have very nice game, very nice and small game in C++ easily, which helps us to proceed and progress in learning in a more convenient and engaging way. Thank you for watching.